Hello, I welcome you all in this course on steam and gas power systems. Today we will discuss on steam generators. Now, steam generators are used, as it implies from the name itself, they are used for generating steam. And in a Rankine cycle, if you remember, temperature and entropy diagram. State 1, state 2, state 3, 4, 5 and 1. So, process state 1 from process state 1 to state 4, sorry, from process from state 4 to state 1 takes place inside the boiler. After pumping, when the pressure is increased through a pump, the fluid or the liquid or feed water goes to the boiler, and this heat addition in heat water takes place inside the boiler. So, basically boiler in a thermal power plant or in a Rankine cycle is used for steam generation, and this steam is subsequently expanded in a turbine, and that is how the output is attained from the cycle. Now, in this course we will be covering the boilers, there are steam generators, boiler systems and the type of boilers. Now, by definition, a boiler is an enclosed pressure vessel where heat generated through the combustion of fuel is used for converting water into the steam, because here the feed water is going to the boiler and subsequently it is converted into the steam. But when the water is converted to the steam, there is an enormous increment in the specific volume of the water. It is approximately 60, it may go up to 2000 also. So, it is approximately 1600 times, but the boiler has some confined space. It is almost constant volume. That is why instead of increasing the volume, the pressure is increased. So, the steam available from the boiler is at high pressure and high temperature, high pressure and high temperature. Now, regarding the requirement of a good boiler, because before we design anything, we study any equipment, we understand what are the requirement of that equipment. The requirement of a good boiler is maximum quantity of steam at required pressure, temperature and quality. It is obvious, when we are installing or purchasing a boiler, it should give maximum quantity of steam at required pressure, temperature and quality. There are three things which are important, not only pressure and temperature, but quality of the steam, whether it is a wet steam or superheated steam, that is also equally important. Light in weight and compact. Boiler has to be light in weight, so transportation is easier. It has to be compact, it should occupy the minimum floor area. Safe in working with minimum joints. A boiler should have, because it is a high pressure vessel, so if it has minimum number of joints, the chances of leakage will also be minimized. Initial installation and maintenance costs should be low. So, anything we purchase, it has to be low cost and high quality. So, same is the case here. So, initial installation and maintenance cost should be low. Capable of quick start and should meet the fluctuation in the demands. So, demand of steam in any prime mover is not constant. It may vary and it may depend upon the load. So, the boiler should be able to, or boiler should be capable of meeting this fluctuation in demand. All parts should be accessible for inspection and repair, because boilers are always under inspection, right. So, all the parts should be accessible for the inspector for the inspection and for of course for repair as well. There should be a minimum refractive material used for the boiler, because later on in subsequent lectures I will explain you in details the working of the boilers. Then you will find that the refractory mason work is also an integral part of a boiler, that we will discuss later on. Heating surface should be free from contamination, because if contaminations are there, the heat transfer will not be very effective. So, the heating surface should be free from contamination. Now, regarding the boiler systems, every boiler or every machine has certain systems. So, regarding the boiler systems, number one is water treatment system. Now, water treatment system means we cannot use tap water in a boiler, because TDS of tap water is quite high and it is not permissible to be used, it is not permitted to be used in a boiler, because when the water heating takes place in a boiler, the solubility of salts in water reduces drastically when temperature exceeds 44 or 45 degrees centigrade, and these materials, they get precipitated on the surface and scaling is formed, and this scaling works as an insulator. Suppose there is a boiler tube. If scaling is done on the surface of the boiler tube, this will hamper the heat transfer, right. So, in order to avoid this scaling, the water treatment is done. Ideally, we should use distilled water in a boiler, but distillation is a very energy intensive process. So, instead of distillation, demineralization of water is done, and the water with less than conductivity of less than 5.0 microsiemens per meter is used for feed water in a boiler. Now, this is microsiemens. Now, Siemens is inverse of ohm. If you remember your electrical engineering, then resistance of any conductor is proportional to length of the conductor and the area of the conductor, and resistance is a constant. There is a constant specific resistance L by A. Now, specific resistance rho is RA by L, and the unit of this specific resistance is ohm meter. Now, conductivity is opposite of this, 1 by rho. So, it turns out to be 1 by ohm meter, and this 1 by ohm is known as Siemens S, it is denoted by S. So, the conductivity of the water is expressed in terms of Siemens per meter. Conductivity of the water has to be less than 5.0 microsiemens per meter. That reflects the purity of water. Now, potable water can have conductivity up to 50 Siemens microsiemens per meter. Now, seawater, if you look at the seawater, can never be used for the boiler, but if you look at the conductivity of seawater, it turns out to be 5 into 10 to power 6 microsiemens per meter or 5 Siemens per meter. So, it is quite high. I am just giving you the values to compare the quality of water. So, here ideally in a boiler water has to be distilled water, but we cannot use distilled water. So, we use the water with a electrical conductivity of less than 5.0 microsiemens per meter. Now, there is in addition to this water treatment system, there is another system which is known as feed water system. Feed water is the water which goes to the boiler, but it does not go by its own. So, there has to be a system in place. Now, feed water system includes a feed pump and a feed check valve. Now, a feed check valve is a sort of non-return valve, because when the water enters the boiler, the pressure of this fluid will rise and backflow may take place. So, the feed check valve is sort of a non-return valve which is used in the boiler and which does not allow water to flow from boiler towards the pump. So, there is only unidirectional flow of the feed water, and in addition to this, there is a steam system also. Now, a steam system means the steam is generated in the boiler. In almost all the boilers, it is stored in a drum, right? Now, it is stored in a drum. The steam from the drum is taken if we want to do the superheating of steam. Now, when the steam is stored in a drum, part of the drum will be filled with the water, saturated water, and part of the drum will be filled with the steam. So, you will never get a superheated steam. So, here in this case, what we do, we provide a pipe which takes saturated steam to the boiler or to the flue gases, and then we get a superheated steam from this outlet, right. In addition to this, there is a steam check valve, and there are number of safety valves, right. So, it includes they are included in steam system. Now, fourth is blowdown system. Right. Now, blowdown system is there. It is a blowdown valve, okay, and it is provided at the bottom of the boiler. Suppose you have switched off the boiler. When you have switched off the boiler, it means you are not supplying any heat, or it is disconnected from the you are not providing any fuel to the boiler. So, subsequently the boiler will switch off, and whatever water is available in the boiler, it will be blow down through this system. So, a boiler has to be a boiler must have a blow down system also. Fifth is fuel supply system, right. A boiler may use solid fuel, it may use liquid fuel. So, if it is a liquid fuel, there has to be liquid fuel pump which will pump the liquid fuel into the furnace. If solid fuel has to be supplied, there are several arrangements for supplying the solid fuels also. So, this is also a part of the steam generation system. Air supply system, and 7 is flue gas system. Because air available in combustion chamber is often not sufficient. So, air has to be circulated in the combustion chamber. There are two ways of circulating air. Either we use natural draft, or we use induced draft or forced draft, or that induced draft and forced draft are attained by providing fans. So, there is a separate system for air circulation in the boiler. Flue gases also, because the heat exchange takes place between the flue gases and the water. So, for the circulation of flue gases also, there is a system in the boiler, and the chimney and the baffles are provided in order to manage the flow of flue gases in the boiler. There are different type of boilers, and they can be classified on different type of parameters. First is orientation. Orientation of vessel of the boiler, right. If the vessel is horizontal, it is a horizontal boiler. If vessel is vertical, it is a vertical boiler. If the vessel is inclined, it is an inclined boiler, right. Type of firing. It is firing of the fuel. Now, how fuel is fired? In some of the boiler, or initially when the boilers were manufactured, the firing was provided within the boiler. A grate was provided. Now, grate, there is a new term, grate. Grate is a place or a platform. It is perforated, or it has having several rods. And this if I show you the plan of the grate, it is going to be something like this. There are a number of solid rods, right, and fuel lies over these rods. Air is circulated. Suppose this is the grate. Air is circulated through the grates, which facilitates the burning of the fuel. Now, ash formed in the grate, suppose this is the grate, ash formed in the grate is collected in ash pit. Ash pit is just below the grate. So the type of firing, most of the boilers in earlier stage were internally fired, right? The grate was inside the boiler body. Like I will not name the boilers, otherwise you will get confused. Some of the boilers, this combustion takes place outside the boiler. I will give you an example like steam locomotive. If you have seen a steam locomotive, the combustion of fuel takes place outside the boiler. There is a big furnace. Inside that furnace, normally coal or wood stock is used for the fuel was used. Nowadays steam engines are no longer used in public transportation or goods transportation. But that time, because in India, I think in 90s, early 90s, around 93 or 94, all the steam engines were discarded, and now we are using diesel locomotives or electric locomotives. So coal was burned outside, and the flue gases were circulated inside the boiler in order to generate steam, right? So they are externally fired boiler and externally fired boiler and internal fired boiler. Externally fired and internally fired. So old boilers you will find even in new boilers also, many of them, majority of the boilers are internally fired boilers. Now third is based on fuel. Which fuel you are using? The most popular fuel for the boiler is coal, right? Coal is used. Then gases are also used. Even for this package type of boilers, furnace oil is used. Furnace oil is a petroleum product that is used. In small capacity boilers, LDO is used. The LDO is light diesel oil, the normal diesel which is available on the petrol pump. So LDO is used, can be used as a fuel. Furnace oil can be used as a fuel. It is for the boiler. Coal, gas, but gas can be used only for a stationary boiler. For moving boiler, the gas cannot be used, right? And wood stock can also be used if it is available in plenty. Fourth is based on the circulation of air. This I have already told you. Circulation of air, it is a natural circulation of air in the boiler, or the air is circulated using a blower, or a induced draft is created, or air is sucked. There are two types of forced circulation. Suppose in a passage I have to circulate air. One method is I put a blower here and circulate the air in the passage. That is known as forced draft. Another way is I put a fan here or blower here which sucks the air through this passage. It is known as induced draft. So either we can go for induced draft in the boiler or forced draft in the boiler, or it can be a natural circulation. Now another type of classification is extent of fire. Extent of fire means it is a fired boiler or it is unfired boiler. Because in some of the boilers the firing does not take place, hot gases are circulated. Sometimes waste hot gases are available. So these gases are circulated in the boiler in order to generate steam. Another classification of the boiler is tube content. This is a very popular classification of the boilers. But according to tube content classification, there is number one is water tube boiler. Number two is fire tube boiler. Right? In a typical arrangement of a boiler, there is a shell, and there are a number of tubes, maybe a single tube or a number of tubes. Nowadays, most of the, high pressure boilers, they are water tube boilers, where water is circulated inside the tubes and the shell is filled with the flue gases. There can be two arrangements. Either flue gases, they flow in the tubes and shell is filled with the water, or shell is filled with the flue gases and water flows inside the tube. So, when the water flows inside the tube and shell is filled with the flue gases, or the boiler housing, it may not be a shell, that is also true, that in a boiler housing, when the boiler housing is filled with the flue gases and water flows inside the tube, then it is called a water tube boiler. So, most of the modern high pressure boilers, and earlier also number of boilers, they were water tube boilers. Another type of boiler is fire tube boilers. In fire tube boilers, there has to be a shell, and this shell is filled with the water, partially filled. It is not fully filled, but it is partially filled with the water, and fire flows inside the tubes. And number of tubes are also less. Fire tube boiler, there may be one fire tube or two fire tubes. Now, these two classes of boilers will be separately discussing in two subsequent lectures. Next lecture will be on fire tube boiler, then another one will be on the water tube boilers. So, these two boilers, a number of these two boilers, the number of fire tube boilers and number of water tube boilers, we will be discussing in those lectures. Now, what are the advantages? Because there are two types of boilers. So, this may have certain advantages over this and this may have certain advantages over this. Now, the advantage of fire tube boiler over water tube boiler, the advantage of water tube boiler over fire tube boiler. The biggest advantage is that the safety. Suppose, because the steam we take from the boiler is a high pressure. As you have seen in the previous lecture, the steam was supplied at 40 bar. So, when this steam is filled in the shell, right, by accident, suppose this shell bursts, it is going to cause enormous damage. Now, instead of that, the high pressure steam flows inside the tube and it is housed in a shell. Damage will be less. I don't say that there will not be any damage. Damage will be there, but damage will be less severe, right. That is why most of the high pressure boilers, right, they are water tube boilers. But definitely fire tube boilers has certain advantages. So, advantages of fire tube boiler we will start with. First of all, they are very flexible. Fire tube boiler, they are flexible in operation. What is the meaning of flexible in operation? Because the entire shell is filled with water. Suppose there is sudden demand of, more demand of the steam, or there is sudden drop in the demand of the steam, it can be accommodated in fire tube boiler. It can be done in water tube boiler also, but conveniently it can be done in fire tube boiler. That is the one advantage. Second is, if there is a feed water failure, say failure can take place anywhere and at any stage. In water tube boiler, right, if feed water failure supply system fails, overheating of tubes will take place. In case of fire tube boiler, because shell is filled with the water, so if there is a failure in the supply of feed water, the damage will not be that severe. So, that is another advantage of fire tube boiler. And the third one is maintenance is low, simple and maintenance is low. Their maintenance is less. Why maintenance is less? Just simply saying maintenance is less will not become less. It is less because in water tube boiler scaling takes place. So, if there is a bundle of tubes, so each individual, each of the tube has to be cleaned. Nowadays, they are cleaned with the help of chemicals. So, the maintenance cost of water tube boiler is higher in comparison to the fire tube boilers, right. Now, again, we will discuss the advantages of water tube boiler. boiler. First of all, safety. Okay, so if accident takes place in water tube boiler is less severe. Steam generation rate is large. Steam generation rate is large. Further, we can operate on higher pressure. Why we can operate on higher pressure in water tube boilers? Because pressure is the pressure of steam, and in any cylinder, stresses are, hoop stresses can be expressed by PD over T, right. Now here, for the same thickness, if the diameter is increased, or in order to maintain same level of stress, if we increase diameter, thickness of the plate has to increase. Now in fire tube boiler, steam is filled in the shell diameter may be 2 meters or 3 meters, right. Accordingly thickness has to be taken, for shell thickness has to be taken. However, in the case of water tube boiler, the diameter of the water tube may be 1 inch or 2 inch, 2 centimeter or 3 centimeter or 4 centimeter. So we can go for the same thickness, we can go for very high pressure. So normally high pressure boilers are therefore water tube boilers. So in water tube boilers, the maximum pressure can go up to 100 bar, 150 bar. In fire tube boiler, the pressure is restricted to approximately 20 bar. Normally we don't go beyond 20 bar. And second thing is, the water tube boiler are easy to fabricate because shell is not under pressure, right. So the main part which is under pressure is the tube of the boiler. So they are easy to fabricate and install and assemble at the site, right. So if we compare fire tube boiler with the water tube boiler, so the pressure is, fire tube boiler is approximately 20 bar. Here it can go to, we can go very high pressure, we can go up to 200 bar, 300 bar pressure, right. Because in supercritical thermal plants, these water tube boilers are used. So it is, so the pressure, in fact the pressure in the water tube boiler is decided by the metallurgical limits of the material, to what temperature the material can sustain. Efficiency of this is 80-85, it is slightly more, 85 to 90%, and sometimes in some of the fire tube boilers it is 70%. In old, if you look at the old efficiency of the old fire tube boiler, it is 70, 65 or 70%. So efficiency is also high for a water tube boiler. Inspection is fire tube boiler. Inspection is easier in fire tube boiler. In water tube boiler, inspection, I mean, because there are a number of tubes, so inspection has to be frequent, and I mean thorough inspection has to be done in water tube boiler. And basically because the scaling, the problem is scaling, that has to be taken care of. So frequently, first of all, we have to ensure that the feed water is, in both the cases, that is true for both the cases, the feed water does not have this TDS. TDS is low for the feed water, or the conductivity is less than 5 microsiemens per meter, and the frequent cleaning of the tube has to be carried out in water tube boiler, right. That is not the case in the fire tube boilers, right. So in the next two classes, first we will start with the fire tube boiler in the next two lectures. First we will start with the fire tube boilers, and then in subsequent lecture we will take up water tube boiler. We will be taking certain examples, right, of fire tube boilers and water tube boilers. That is all for today. Thank you very much.